Hey everyone, on today's episode of Careers Out There, we're going to explore careers in biomedical engineering. We'll be talking to Amy Patel. She's a biomedical engineer in the pharmaceutical industry in San Francisco. Amy's so passionate about what she does that she started the Biomedical Engineering blog designed to help teach others about the subject. You can find that site at amyshah.com. That's Amy, S-H-A-H. On every episode of Careers Out There, we explore a career path by talking to a real professional who does that kind of work. They tell us what it's really like and then share all kinds of advice to help you decide if it's a path that you want to pursue. I'm your host, Mark Luber, and I'm really psyched to be learning about this cutting-edge career path today. It's going to be a great show, so stick around. Okay, we're back. Amy, welcome to Careers Out There.
Thanks, Mark. I'm happy to be here.
Thanks for being here. So, Amy, biomedical engineering is such a cutting-edge path, and everything I'm reading about it is saying that it's really just kind of developing now and coming into its own as its own field. And so first I want to say that that makes for a great opportunity for our viewers, because if anyone's really thinking about getting into this, it's always good to be getting into things that are new and growing, because that leaves a lot of room for upward mobility, which is awesome. Let's first start by you telling us what biomedical engineering is.
Biomedical engineering is the application of engineering principles and applied sciences to medicine, the human body, and the way that biology works to create life.
Wow. So can you give us some examples of biomedical engineering in action and tell us some applications that would relate to our lives so we could all understand it?
Definitely. One of the things that I think is the coolest is the Da Vinci. It's a robot that actually performs surgeries, and that is a huge biomedical engineering accomplishment. Some other things that you may have heard of are tissue engineering, artificial organs, stem cell research, and also pharmaceutical development of drugs like synthetic drugs that are made purely in the lab, not from things like plants or other animals.
Wow, so I assume this field must be really important to, let's say, veterans coming home from Iraq and Afghanistan, right?
Definitely. Definitely. Things like artificial limbs made out of artificial organs really help a lot of the veterans that come back into this country, after injuries.
This all sounds so cool. Tell us some ways that this plays out in real life, some more examples so that everyone at home who's never dealt with biomedical engineering can relate to it and can understand it.
Yeah, definitely. There's so many different things that you could do to help society. For example, in Europe, there was a 21-year-old that lost both of his arms, by being electrocuted. So basically, biomedical engineers surgically implanted electronic arms onto him, and he was able to live normally. He was able to brush his hair, to drive his own car that was designed for him, and everything. So that's something that really helps people all around the world. Other things are like stem cell treatments. There's different types of adult stem cell or embryonic stem cell treatments that help people with all sorts of diseases, and we still haven't even unlocked all of the potentials in that yet. My favorite is tissue engineering. I used to do tissue engineering research where I made a triple cell culture of an actual, respiratory tract of a person. And so that could basically, in the future, help people with asthma breathe better. And things like that, it's really limitless in this industry. It's amazing. We're just scratching the surface of it. And being a part of it, you can really help people later on in your life.
So with tissue engineering, would that be... Tell me if this is an example of tissue engineering. I recently heard a story, and I believe it was rock star Keith Richards' wife had a fake bladder made because she had bladder cancer. And but it wasn't just like a bag. They used to, I think, just throw a bag in there. Like if your colon was removed, you get a colostomy bag or something. And my understanding is that this is actually like an artificial bladder, but made out of her own body, her own cells. Is that tissue engineering?
That's definitely called tissue engineering with use for artificial organs. So just to go a little bit off that example, putting just a bag in your body is not going to help. It's not going to expand and contract like a normal bladder. It has limits. So that's a disadvantage of using something like that. And then if you transplant an organ from another person, your body can reject it because your blood and your cells are different than that person. So artificially creating an organ is creating it so that it will stay within your body and also act like similarly to a normal organ in your body instead of just a bag using for a bladder. So yes, that's definitely a great example of artificial organs and tissue engineering and, maybe even stem cell implantation in the future.
Wow, so cool. So tell us this then. What specifically is a biomedical engineer doing when it comes to tissue engineering? How are they applying what they've learned and what's going on in a lab?
That is a great question. A biomedical engineer can be involved in different biomedical engineers would be involved in different steps of that process for the example use. So for example, there may be biomedical engineers that are working on the actual research of it in the lab that are creating that. And then there would be the next step would be creating it for that specific person, which is different people because it's not in a lab setting. It's going to go into a real person. And then another part is during the surgery, implanting it into the person, there may be a biomedical engineer present, watching or making sure that the organ or whatever they created is acting as it's supposed to, both before it gets into the body and after it gets into the body. So there's a lot of different steps that go on in the process.
Wow. And then I would assume that the odds of any kind of rejection, like when you get a transplanted organ, I would assume the odds of any kind of rejection are way smaller when it's being done this way, right?
Definitely. You can check that out on my website too. I have a lot of blog articles about reducing the rejection of transplanted organs by using artificial organs. And also, there's not as many donors as people that need organs. So artificial organs are definitely in very high demand.
Wow. And what's stopping all these things from being so commonplace? All the stuff that you guys are doing, what's stopping it from being just everywhere?
There's a couple things. One of the biggest things is ethics. A lot of people are still scared and not as well educated about stem cells. They don't understand that it doesn't necessarily have to come from an embryo. There are adult stem cells or, even stem cells in your body that you could use for yourself. So there's a couple different things about that. And then another thing is just, research. We're still, like I said, scratching the surface. We're getting there. We're getting there slowly but surely. So there's a lot of trials that need to be done on both animal trials and people before all these things can be available on the market to everybody.
So when we hear about things like cloning of cows or cloning of sheep, is that being done by biomedical engineers?
Definitely. That's one of the biggest reasons that biomedical engineering became a separate field from chemical or mechanical engineering is because of cloning.
Wow. So you were telling me over the phone that there's a lot of subfields of biomedical engineering, and I was reading about that even on Wikipedia. They were mentioning that there's so many subfields. Can you tell us about some of those?
Yeah, definitely. Some of the subfields are like nanotechnology, which is the study of really, really tiny particles or fluid motions. Then, of course, there's tissue engineering, research. There's actual engineering paths where you can go into like quality engineering, reliability engineering, safety, et cetera, et cetera. So there's tons of things that you can go into that can spark your interest. And even people like mechanical engineers and chemical engineers often go into the field of biomedical engineering because of the diversity.
Oh, wow. Okay. And then you were telling me even that someone could be a salesperson because they could combine their personality with their technical skills. Is that right?
Yes, biomedical engineers make great salespeople for pharmaceutical products or medical devices because they could actually explain how the product works in real life since they would come from that industry and they have that background knowledge of whatever they're selling.
Okay. Wow. First I want to tell the audience too, I'm a total science idiot. So just in case anyone's hearing that I'm not questioning certain things or that I'm glossing over certain things, that's because some of this does go over my head because I am a science idiot. So I just want to make that clear in case someone's wondering. You told me over the phone that there's a certain goal that so many people have that enter this field. I thought this was really interesting. Tell everybody what that goal is.
Yeah, really common thing that you'll see in this industry, no matter what subfield you go into, is that people are really trying to better society through their work, whether it's through drugs, through artificial limbs, through research that they're doing. It's really to help the betterment of mankind or, help people with cancer, Alzheimer's disease, aging, things like that. It's a really inspirational field where you can really feel like you're making a difference in the world.
And is that what led you to this path?
That's definitely the first thing that attracted me to this industry.
Wow, very cool. So tell us then what you do and what your role is in biomedical engineering.
Great. Right now, I'm a reliability engineer at a pharmaceutical company. So we help manufacture drugs for chronic illnesses such as rheumatoid arthritis, cancer, diseases that stunt child growth, things like that. Basically, long-term, lifelong diseases where people need these drugs to live.
Wow, and what does reliability engineer mean? What does a reliability engineer do?
What I do as a reliability engineer is I make sure that all of the big machines that are creating these drugs like fermenters, boilers, all these huge machines are working properly to manufacture the drugs perfectly to every single tiny microgram that's being manufactured.
Wow. So are you like a mechanic in a sense?
I'm not a mechanic, but I do analyze all of the data to make sure that the mechanics are keeping up with their maintenance properly on the equipment. And if a piece of equipment does fail, I do things like a root cause analysis to make sure that the equipment is performing properly, or to see if we need to purchase new equipment in order to manufacture the drugs properly for our patients.
Okay. Okay. It's like the car dealer kind of.
Kind of.
Have to make sure everything's running properly, take it in, get it checked. Tell us about a typical day for biomedical engineers. You could take into account what you do and then also what you know about some of the other fields, if there's some commonalities that we could talk about.
So a typical day in my field as a reliability engineer at a pharmaceutical company is I do attend a lot of meetings to represent my knowledge base and my technical knowledge. I also do a lot of data analysis on the computer and generate a lot of reports and recommendations for people to move forward with what they're doing to ensure that the quality of our product is what we're promising. Other biomedical engineers can be involved in things like day-to-day research, many meetings representing their technical base, grant writing to raise money for their company or their organization that they're working for. And also a lot of things that people do is giving presentations on what they're doing. There's a lot of different things you could do based on if you'd prefer to work on your own or as part of a large team. A lot of things that we do are being part of a project to make sure that we represent the human body and the engineering principles correctly. A lot of the mechanical engineers or other marketing people that work on these things don't understand what goes on in the human body and the engineering principles behind like fluid dynamics or other things that affect the end product.
Hmm. So then you'd say there's a lot of variety within each day. It's not like you're just sitting at a desk. You're doing a lot of different things within a day.
Definitely. That's what I love. I could do something different every day. But another good thing about it is that going into this industry, whether you like working individually or as part of a team or presenting to people, you could pick what you'd like to do and go into that job eventually based on your interests.
Okay, so then there's really something for everybody.
Yeah, definitely. I think so.
Um, let's talk about high school. What should someone like in school if they want to go down this path?
In high school, the important subjects are definitely biology, chemistry, math. If your school offers advanced physics classes or even an advanced medical science classes, I would definitely say to take that to learn a little bit more about what you would be getting into in real life. And another useful thing to do is that there are internships that you could take even in high school. You just work for free and get experience at a company. And I would say that's really important when choosing your college major.
Well, so you can even do that in high school?
Definitely. You can definitely intern at a company in high school. You just have to have that initiative, go out there and get it.
Wow, interesting. God, I wish I was good at those classes. Those are all my worst classes, other than economics. Those are my worst classes. I could not do. They were interesting, but I couldn't do them. I'm an English major kind of guy, but this stuff sounds so fascinating. I really love, especially the fact that it's one of those wanting to help the world kind of jobs, and the fact that it is so cutting edge and really pushing everything into the future. So I hope anyone listening who's interested in science and math is really paying attention, because I think this sounds like just a great opportunity to jump into. Let's talk about college now. College classes and college majors. Do you major in biomedical engineering?
Yes, you can major in biomedical engineering, and at some schools it's called bioengineering. It's pretty much the same thing. Some people that get into this industry prefer to like double major or major in something different if their school doesn't offer it, like chemical engineering or mechanical engineering, and you can still go into biomedical engineering from those fields.
Wow. Okay. So you just have to also have the bio background. You just don't necessarily have to major in it.
Yeah, you would just have to take some extra bio classes. I know that some schools still don't offer biomedical or bioengineering for an undergraduate degree. So I would suggest, taking extra biology classes or, maybe taking classes over the summer at another school that does offer the biomedical engineering classes would be a good advantage to get into the industry or see if you even like it first.
Yeah. And then if someone's starting at college and they didn't know in high school that this is what they wanted, but they're interested in the general concept, they should just start taking as many science classes.
They should take specifically biomedical engineering classes. A lot of school offer like entry-level biomedical engineering course so you can learn about all the different industries and what you can possibly do in the future.
Wow, okay. And are there certain colleges, certain parts of the country where people really should be looking for these programs, or are they pretty much popping up at a lot of universities now?
Nowadays, they are popping up at a lot more universities, but I would definitely say in places like the South or the Midwest, it's more rare. Maybe not impossible to find, but more rare. But definitely the two coasts, the East Coast and the West Coast, would be easier to find a biomedical engineering major at bigger colleges.
Is it kind of a combination of pre-med with engineering?
Yes, I would say, that's definitely accurate. I can give you one small example is there's blood flowing through your arteries 24/7. And so basically that blood puts a lot of shear force on your arteries. So knowing things like the thickness of the arteries and the viscosity of the blood and the shear force are all engineering principles, but within the body, there's different cells in there and stuff. It's not just water or a liquid. And so that's the combination of engineering and medical principles that you're talking about.
Okay, wow. It's also interesting. And what about grad school? Is it possible for someone to build their career on a bachelor's of science, or do they really need to go out and get a higher level degree after that?
That is a great question. An engineering degree in any type of engineering, whether it be biomedical, chemical, electrical, mechanical, is a great degree to have, even if you just want an undergraduate degree with no advanced degrees, because you automatically go into the profession of engineering. Whereas, things like biology and economics, you kind of have to specialize a little bit more. You can, of course, go to grad school to further specialize in like photodynamics or tissue engineering or any of the other topics we've talked about. Other things that people do is get their PhDs or their MDs, or you can even get your MBA afterwards. So it's pretty diverse and open after your undergraduate degree.
Wow. Okay. So lots of different ways you could spin this one.
Definitely.
What first attracted you to this? We were talking about your interest in helping the world, but how did you first hear of it? Did you know about it in high school? Did you figure it out in college?
In high school, I was really motivated to figure out what I wanted to do. A lot of people around me wanted to do different things, and they knew what they wanted to do. I myself did not, which is very common.
Yeah.
So basically what I did was I just went out there and figured it out. I went on Google and looked at a lot of careers that were in demand and careers that could help people. I knew I didn't want to be a doctor or work in a hospital, but I knew I wanted to help people and be something in the medical field. It's a huge field. There's so many careers out there for people.
Yeah, for sure. I love that. You found it through Google. You figured it out through Google. That's so crazy.
Yeah.
I love it. What skill sets would you say? Beyond formal education, what skill sets would you say people really need to bring to the table to go down this path?
You definitely need to be a hard worker. You need to be motivated, never be able to give up. But one of the biggest things is that you need to have an analytical way of thinking. So for example, if you're looking at a lamp, you see it as a light bulb, a shade, and then an electrical socket that's coming out of somewhere. It's different components that you see that you put together as one. That's a great way to think. A lot of people that go into engineering, when they were young, they played with Legos a lot. That's one of the really big indicators that you're maybe made to be an engineer.
Wow. Very interesting. That's great. So many people love Legos. And Legoland in San Diego, I guess that's a place you could go and kind of.
I love that place.
Yeah, were you a regular there, hanging out all the time?
I've only been there a couple times, but I loved Legoland.
That's hilarious. Not too far from Irvine.
Yeah.
What else? What other skills other than analytical thinking? Team player.
Yeah, it's definitely not necessary to work in a team. For example, in a research environment, a lot of people can work on their own, but most of the jobs out there are definitely working as part of a diverse team. So not a team of biomedical engineers.
Tell us that. Who does a biomedical engineer interact with on a daily basis? What type of people? What type of roles?
So on a daily basis, you would interact with other engineers like electrical or mechanical or even chemical engineers, depending on your job. And you definitely interact with a lot of project managers asking you a lot of questions that they don't understand. Project manager basically puts everything together, but maybe doesn't understand each individual component. And then there's other people that are also involved like marketing, branding, business development people that want to know, okay, what you're working on, is that going to take our company to the next level? Or is it going to put our product in that pipeline to make it where we make more money moving forward to fund what we want to do to help people? So there's a lot of different types of people that you're working with that you need to explain different things to because they themselves have different backgrounds as well. I myself, as a reliability engineer, work with quality engineers, validation engineers, and a lot of business development people as well.
Now, when you're talking about the business development people and the marketing people, I assume that they are not engineers. They do not have a science background. They're just very interested in this field, and that's why they're there.
Yes, typically they don't have a science background. They might have like an economics or business degree background, but to run a company, you need a little bit of everything.
Yeah. So they're relying on you for your expertise.
Exactly, and then us on them as well. I don't know how to make the packaging to sell a product properly, but they do. So we have to bounce ideas off of each other.
Yeah, yeah, that's great. What about the most rewarding aspect of this path? Other than we mentioned changing the world, helping the world, what else would you say?
I would definitely say seeing things go from point A to point Z, seeing how much work is involved in it, how much time, how much commitment involved in something. As a biomedical engineer, it's really cool because you can see things from beginning to end, whereas somebody that's in marketing might see things more towards the tail end. We get to see a lot of the research and development, and then we also get to see things go to market. So that's really cool because you could apply that to different industries. For example, even Anheuser-Busch, the company that ferments and makes beer, I have a lot of knowledge about all of the instrumentation involved in pharmaceutical manufacturing, which is actually very, very similar to fermenting beer. So it's something that you're able to apply to different industries, and it's just pretty interesting, to see things go from nothing to this huge thing that everybody knows about.
So does everyone stay late after work on Fridays and kind of push the cancer drugs and the arthritis drugs out of the way and start brewing some microbrews there?
Hey, you could definitely do that with our equipment.
That'd be fun. That's yet another reason to go down that path. So what's the most challenging aspect of it?
The most challenging aspect, I would say, is working with the different types of people, and also when things don't necessarily go your way. When you're working at a big company, you have a lot of resources, but I've also worked at a small company before where we don't have as much money, we don't have as many employees, so you're, stretched a little bit thinner, and it's just being creative with what you have and having that positive attitude to make you pull through everything. But, if you're working with good people and if you have a good attitude about it, you can definitely do it. But there's always challenges no matter what field you choose to go into.
Absolutely. Absolutely. What about this? You were telling me over the phone that a lot of times people aren't even familiar. People in your own industry might not be familiar with what biomedical engineering is. And did you tell me that it's kind of in the industry called BME? Is that?
Yes, so BME would be our short version of biomedical engineering,
Okay.
and you're correct. It's something that's been around for a long time, but it's never really had like a set name. More mechanical engineers or chemical engineers would go into these biotech companies, and so more in the recent years, biomedical engineering has been more widely recognized, and so it's a little bit frustrating trying to explain to people that we're not just biology majors. We've taken a lot of advanced calculus courses, a lot of physics courses, so we understand fluid dynamics, biomechanics, all those kind of things. So those are definitely things that are a little bit difficult to deal with, but you get through it as long as you have the right knowledge, you're able to explain it to others.
What about this? You were telling me that sometimes the real world is very different than the education world, the school world for an engineer, and translating it into real life can be a tricky thing. Can you tell us about that?
Yeah, if I can give you an example about that, that would be great.
Yeah.
Basically, when you're in school, you have a lot of direction, people telling you what to do, giving you instructions, helping you along the way of your path. When you're in the real world, you basically are just given a problem and figure out how to do it. You're not given, what you need to use to do it. So for example, on one of my first jobs, I was doing research, and the cells that I was working on in my research lab wouldn't fit into the dishes that we had to grow them in. And so the postdoctorate that I was working under just said, well, we need to grow the cells in here. This is what we have. Figure it out. And he didn't give me any other information or anything to figure it out, and he just walked away to go write the rest of his grant proposal. So that was a big challenge that you don't learn about in school, and you just have to be open-minded, work hard, and I succeeded eventually after that. It took me hours and hours of research of what to do, but I did it, and you just got to figure it out.
That's great. Thinking on your feet. That's the real world.
Yes. That is the real world.
Absolutely. And yeah. What about this? You also were saying earlier that there's something for everybody out there. There's ways to kind of tweak your role so that you find the thing that fits your interests and skills. You told me over the phone that there are some people don't like the engineering aspects of the path. Maybe the drawings aren't really their thing, but the science, the biology aspect is more of interest. How does that work out? And what is, if someone starts working, they get out there in the real world and they realize that they realize that their strengths are not in the drawings and not in the engineering aspect. What do?
Yeah, that's a great question. There's a lot of people like that in this industry. I would say maybe like even half the people in this industry are like that. And it's good because they have the engineering background, They got a really good solid knowledge base of the engineering. So they may go into something like research, they may get their PhD, they may become a professor and go into teaching. A lot of other things that people do are related to that industry. So for example, you can work at a pharmaceutical company and be a salesperson and sell the drugs, and you could still make good money and use everything that you've learned in school. Or work at a medical device company because you have a degree in BME and be a salesperson or marketing person on that end as well. I've seen a lot of people do that, and they're very successful and they're very happy with what they do.
Nice. Nice. What about this? What's the weed out factor? I always like to ask this. This would be the thing where if you can't handle this, you really shouldn't be in this path. You shouldn't be going down this path at all. What would that be?
I would say a big weed out factor is just not being able to consume and understand numbers that well. So it's not the end all be all because it's a very diverse industry. But I think even when you go into sales or when you go into marketing, you still need to understand numbers. You need to understand statistics and what these numbers have as an effect on people. So for example, if the statistic of something is 1 in 3 and you're trying to sell somebody, depending on whether that's a positive or negative statistic, you want to know how to spin that. So that really, I think you have to be a numbers person no matter whether you're looking at drawings or generating reports or doing sales.
Wow. Okay. All right. Numbers person. Remember that, everybody. You got to be a numbers person. What about employment? Everyone wants to know about jobs. If you're coming out of school now, where should you be looking? What types of places should you be looking for employment?
This is a great growing industry right now. I would say a lot of the big companies or startups, if you have startups in your area, like San Diego has a lot of pharmaceutical startups, and the Bay Area has a lot of biotech and pharmaceutical startups as well. So pharmaceutical, biotech, research labs, places that basically have a large volume of things and a lot of money. That's where you'll be able to find a lot of jobs. However, there's a lot of small startup companies where you learn a lot more initially, even though the companies have less money. Hey, it's kind of like you can learn a lot, and something might happen with the company, it might not work out, but you still got great experience where you can go on to your next job after that, the job that you might be able to have a more specialized role in.
Right. And what about this, internships? You mentioned that in high school there's opportunities. Do you see a lot of opportunities in this space for college internships?
Definitely. I know tons of students that are in college right now that work at large, pharmaceutical companies or even smaller companies. There's legal firms that do want college students that have a science knowledge, maybe on some of their cases and things like that. So that's something kind of cool. You can go into maybe a company that's not biotech or pharma and still get great experience. I even know somebody that got an internship at the FDA, the Food and Drug Administration, and that's, it's always great to know the laws in this country before you go into industry as well. So there's a lot of internships out there. You just got to go get them. You can even intern at companies like Coca-Cola or Neutrogena, things that you might not initially think are applicable to your industry, but you will learn things that will help you later on as well.
So do companies like those even have biomedical engineers? You would have someone in your role at a Coca-Cola kind of place?
They'll probably have things like people for research or chemical industry, which are really relevant to biomedical and pharmaceutical industries as well. But the biggest thing will probably be that they would land a role in research and development or marketing. And marketing for things like over-the-counter drugs, which Neutrogena manufactures, is somewhat similar to pharmaceuticals as well. So I would say it's definitely worth a try. If that's what you get, then go for it.
Wow. Okay. Yeah, internships, you guys, are so important. I broke into the music business that way. That was my first career before getting into the career consulting recruiting space. And it's all about internships. That's how you meet everybody. That's how you get out there. You get your work experience. You get started. So everyone should definitely pay attention. It's good that they have it in this in such a technical kind of career path. I think that's really good to know. So startup companies, those are there for people who really aren't big fans of corporate America. If they really are interested in that more, just a smaller, cutting edge kind of a thing, the startup opportunities are out there.
Yes, there's definitely startup opportunities out there. And the good thing about a startup company is you get to do so many things initially. So it's a great job right out of college or even in high school if you're able to land an internship there. It's great. You get to do a little bit of every single thing, especially if you get it in high school. Hey, maybe you discover biomedical engineering or some other field from a startup company. So that's definitely a big advantage. And networking is the biggest thing. So when you work at a startup company, you get to meet a lot of new people. That's a big advantage to any industry.
That is red magic marker territory. I always tell people networking is red magic marker territory. Yes, so get out your red magic markers, everybody, and highlight that in your notes. Networking is key. Right, Amy?
Definitely. That's how I've gotten all my jobs, networking.
All right, you guys, you got to do that. You got to do that. Okay, so then we've got pharma companies, medical device, biotech, startups, and even places like Coca-Cola. Or even, you were telling me even like a research place, like a Kaiser?
Oh yeah, Kaiser definitely hires biomedical engineers. Anywhere that has big equipment, where it has anything to do with medicine, you can get a job. And also, like you said, pharmaceutical companies and anything that's large scale manufacturing companies that need help with equipment. You know, other big things like research organizations are like St. John's Hospitals or Scripps Center in San Diego. Those are really big research organizations that hire a lot of people that have science and engineering knowledge. So that's a big advantage of being in this industry.
Okay. So many different places you can go and take this skill set, it sounds like. Learn it and then grow it.
Yes.
Very, very cool. Well, do this. Close us out with some keys to success. Take your experience and kind of take the mentor role, where you are going to give everyone that's watching that kind of head start, a leg up on everyone else, so that they can learn from you who's been out there in the world, and they can get a little leg up on everybody else.
Right. So I'm going to say it again. Networking. Never give up. Meet as many people as you can. Do not be shy. Get involved in your school, in your organizations. Get involved in clubs. Get involved in industry. Just get out there. That's what you need to do. Another big thing is obviously grades are very, very important. But what's also very important in your academics is being diverse. It helps you a lot if you have leadership experience, whether that be in clubs or student government. And it also helps you a lot if you go out there and get a job early. Getting a job just teaches you responsibility, conflict management, patience, which is big in any industry. And another big thing that I would tell high school students out there is research what you want to do. Take a career aptitude test that you could probably get from your career center. If you can't find that, you could find a million things online. And so definitely just get out there and do some research and try to figure it out. You don't have to decide tomorrow what you're going to do for the rest of your life, but at least know your options. Stay open-minded and definitely stay excited about any opportunity, because the world is your oyster when you're 18.
The world is your oyster. I love that. Great advice. Excellent advice for everybody. You guys, as always, at Careers Out There, we're helping you find a career that fits you so you can love what you do, like Amy here. Amy, thanks so much for joining us today.
Great. Thank you, Careers Out There.
I hope this was helpful to you guys. Please leave your feedback, your questions, and your comments in the comment section below the video at careersoutthere.com. And you could find Amy's biomedical engineering blog at amyshah.com, and that's amyshah.com. And you can find episodes of Careers Out There on iTunes, YouTube, Blip TV, and of course at careersoutthere.com. Thanks again for watching, everybody. I'm Mark Luber, and look forward to seeing you again soon. Take care.